Dr. Peter Warden, Dr. Jawood, Mr. Abdel Mohsen Al-Husseini, Your Excellency Dr. Yahya Al-Majali, teachers and excited students, I would like to welcome you all to this special event. We are really fortunate and honored to have Dr. Warden, the Center Director at NASA Ames Research Center, among us today. He will speak to us today about the solar system. This golden opportunity would have never been materialized without the support and generosity of His Royal Highness the Crown Prince Sidi Hussein. This initiative by His Royal Highness the Crown Prince is to introduce Jordanian youth and their innovative on the international stage. The Crown Prince sees this initiative as a learning experience for the youth of our country. His Royal Highness knows that our youth are capable of great things if introduced to a high caliber of people who can help in guiding them. The students in this auditorium represent the cross-section of Jordanian high school students. Our guest speaker, Dr. Warden, received his BS degree from the University of Michigan in physics and astronomy. In 1975, and soon after he graduated from the University of Arizona with a PhD in astronomy, he entered the United States Air Force. Throughout the 1980s and the early 1990s, he served in every phase of development, international negotiations, and implementation of the Strategic Defense Initiative. He then served as Deputy Director for Requirements at Headquarters Air Force Base Command, as well as the Deputy Director for Command and Control with the Office of the Deputy Chief of Staff for Air and Space Operations at Air Force Headquarters. Dr. Warden is currently the Center Director at NASA Ames Research Center. In that capacity, he is responsible for a civil service workforce of almost 1,300 people, a support service contractor staff of approximately 2,500, and an annual budget in the 800 million range. He manages and leads one of the nation's premier research laboratories, an organization that enables NASA's and the nation's aeronautics and space exploration missions and provides critical technologies to benefit life on Earth. During his tenure at Ames, Dr. Warden has completely transformed the center, reinvigorating its workforce, missions, and putting it on bold new path of research and technology development. Dr. Warden has been honored by major awards and decorations, such as the Air Force Distinguished Service Medal, the Defense Superior Service Medal with Oak Leaf Cluster, the Legion of Merit with Oak Leaf Cluster, the Defense Military Service Medal with 3 Oak Leaf Clusters, and so on. Please help me welcome Dr. Warden to the stage.
Thank you and good afternoon. I'm really honored to be here in Jordan. I'd particularly like to thank the Crown Prince for hosting me. You know, the United States is embarked on some really exciting space efforts, and I'll tell you a little bit about them. But no one country is able anymore to do these things by itself. We are seeking partners around the world. We find that by working together, we get the best effort and the most affordable one. So we are particularly looking forward to working with Jordan and its students. We hope that many of you will come and work with us. We have some exciting work in the next few decades. We're going to expand into the solar system as humanity, and we're going to fix problems here on Earth. So these are rather ambitious goals, and we're going to have to work together. So I'm, again, honored to tell you a little bit about what we do. Now, as was mentioned, I run one of NASA's centers. NASA has 10 centers that do our work. I think the other 9 are okay, but ours is the best. We're based in the San Francisco Bay Area. We all currently like to think we have an 11th center. It's the International Space Station that has now become fully operational. And we hope that many of you will have an opportunity to do research and maybe even some of you to go and fly them. Let me talk a little bit about Ames Research Center. As I noted, we are in the San Francisco Bay Area. We are right in the center of Silicon Valley. Interestingly, we were the first high technology organization in Silicon Valley. We founded in 1939. Since then, there have been others that moved in there. Right next door to Ames is a small company you might have heard of called Google. Google is increasingly owning all of our land. You'll see in this picture there's an airfield in the background. I just signed an agreement, so I'm leasing 200 hectares, including that airfield, to Google. So in the future, you might find the Ames Research Center being the Ames Google Research Center. We have a lot of major facilities at Ames. I won't go into a lot of details, but we have the world's largest wind tunnel to do aeronautics research. We have NASA's high-end computer. We try to keep it in the top 10 or 15 in the world. I think we're currently number 12. The Chinese are the top. They have all the top 8 spots. They put a lot of money in the computers. But we think ours are better, but you know, theirs are faster, I guess. But we also are specializing in an area I'm going to focus on a little bit, which is small satellites. In the past, satellites were very large. They would be the size of this stage, very expensive. They cost hundreds of millions of US dollars, if not billions. In the last few years, we've revolutionized space by using very small satellites. Indeed, these are small enough that there are now a couple high schools in America that are building these. We hope that you'll be able to join us. Indeed, that's potentially part of the Crown Prince's initiative. As noted, we have about 2,500 employees. Our budget has gone up slightly. What number you had, we're close to 900 million. But most important, Ames is the lead for student partnerships. We have over 900 students that work with us every summer, and those include high school students. About 150 of those are non-U.S. citizens, and we're increasing our cooperation. Now, I'm not going to go into a lot of details, but Ames is a little different than the other centers because we focus on everything NASA does. About a third of our center does science missions. I'll talk about some of those. About a third of the center works on human exploration technology. For example, when you send a spacecraft to space, in some cases, particularly if there's people on board, you want to bring it back. If you want to get to space, you talk to one of the other NASA centers, particularly the Marshall Space Flight Center in Alabama. But if you want to come home, you have to talk to us. So we think we're very important. Aeronautics, the first A in NASA is aeronautics. We have been working on aeronautics since 1914 in America, when our agency was first formed, the National Advisory Committee on Aeronautics. But at Ames, we're one of the lead in aeronautics. We are working on the next generation air traffic control system. So when you ride on airplanes any place in the United States, NASA is going with you. A very important area. I mentioned small satellites. This is a very exciting area, and Ames is leading that effort, not just for NASA, but throughout the United States. But probably most important to you is we're the lead in innovative partnerships, and these partnerships include with industry such as Google, but also as international partnerships. Now, let me tell you a little bit about what is a big satellite and a small satellite. This picture shows a rocket launched, and you see in the what's called the shroud, which is what protects the satellite that goes to space, a large satellite. That's about the size of a bus, so it's a pretty big satellite. You see the little tiny thing down at the bottom. That's what's called a CubeSat, and there's a model of it over in the lower right. Those are very small, and they actually can ride along for almost for free to go into space. And this is the area that's really changing things, is that we can do a lot with these Cube satellites. Now, as I said, Ames does small satellites. These are big small satellites. They're a few hundred kilograms, and I'll talk a little more about them, and you'll see in the movie at the end of this discussion of a couple of recent ones. But I'm very proud today to say last year we launched 2 small satellites, one which is orbiting very low around the moon right now. I guess fortunately or unfortunately, its mission will land on the 21st of April where it crashes into the moon. It was designed to do that, so not a mistake. We also have a mission studying the sun. The sun impacts the Earth in what's called space weather. The sun has a lot of activity on large explosions, but that space weather can disrupt communications. It could even change our climate. So we're a very important effort. I'm going to talk a little bit about some future missions, but one of them is designed to further study planets around other stars. We're beginning to find that the Earth is not alone. There are planets like the Earth around other stars. And then we have another mission that we're planning later on this decade where we're going to land on the poles of the moon in search for resources, particularly water. Now I mentioned nanosatellites, these little small satellites. Ames has launched about 20 of those in the last year. We have about 30 or 40 more in this next year. But these are what's changing things. And this is the area that I think there's a lot of potential for cooperation on what we call nanosatellites or CubeSats. Let me talk about a nanosatellite. This is a smartphone. A few years ago, a couple of the engineers working at Ames, including some people from other countries, pointed out that this phone has more computing power than anything we ever put in space. It also has all the features of a satellite. So they decided to do something. Well, let's use this phone to control a little tiny satellite, and called it PhoneSat. Now, this is an iPhone, and we did not use an iPhone because Apple does not give us the software. But Google, again, that company next door, gave us the software. It's an open source software, so we use the Android phones rather than the iPhone. Although I will tell you that after we launched Google's phones into space, Apple, who's just up the street, came by and they've given us a bunch for free too. So this was the PhoneSat project, and these are really small satellites. We first launched them on balloons, very low cost test that we could test in the upper atmosphere. You can see a picture of one being flown on a balloon. And then we launched them into space, 3 of them. And they're not very expensive. The parts for these phones only cost about $4,000 US to build the whole satellite. So these are relatively cheap phones. Now this is not a small satellite. This is the International Space Station. It's the other end of things. But we have figured out that we're able to launch satellites from it. And so we launched these PhoneSats from the International Space Station. Here you can see a picture of the first 3 nanosatellites being launched from the International Space Station to give you an idea of the very biggest things we do in space and the very smallest things we do in space. Now, I mentioned international partnerships. We have 2 kinds of partnerships we do at NASA, and particularly at Ames. One of those is to provide students and researchers an opportunity to work with us. And then we also we'll send some of our experts to come and work with other countries. This is an area that we hope to establish, probably starting with undergraduate and graduate students. And then we also do technical collaboration, and we have a large number of countries, but a couple of these we've worked with to launch these little tiny satellites. I particularly note Lithuania and Mexico. We're in the process of, we just launched the first 2 Lithuanian satellites, and we're going to work with Mexico as well. We hope that Jordan will join that group very soon. Now let me talk about NASA's science, and this is a very important area. There's a lot of fundamental science questions, but to me the most exciting one is, are we alone? Is there life off the Earth? And how did it begin? Is there life inside the solar system, on Mars? Is it elsewhere? And then maybe the most important question of all is, what's the future of life in the universe? Are we, as humans, going to expand in the solar system and beyond? And maybe we develop new technologies to do that. And I'll talk about all of these here in a moment. Well, a long time ago, in the last century when I was your age, and I hate saying that because it makes me feel old, we invented rockets. And we started space travel. We went to the moon with the Apollo program. To give you an idea of my age, I was 19 when we went there. So that was a long time ago. But we visited just about every place in the solar system, at least, and flown by it. So very exciting stuff. But this century, we're in a new era. And I put this gentleman's picture up. He's a very famous scientist, Dr. Craig Venter, because he was the first person to decode the human genetic material, the human genome. He is now working on efforts to begin to program biology, starting with bacteria, and I'll talk a little bit about this very exciting effort. We think that in the next century, this century, we'll be able to use biological engineering to enable us to live in the solar system. I also put his picture up because his brother works for me. And I'll get told out if I don't put his picture up. Well, let me talk about the search for life in the solar system. This is the planet Mars. You know, we long thought there was life, could be life on Mars. In fact, in the 19th century, slightly before I was born, there was a contest that a U.S. newspaper did about giving a large prize of money to the first scientist that proved there was life somewhere else in the universe. However, they couldn't show there was life on Mars because that was considered too easy. So it was a very interesting place. Now, about 30 years ago, we went to Mars. And this is one of the early pictures of the surface of Mars. It looked pretty dry and barren. Now, at the time, I was going to school at the University of Arizona, which is in the American desert, and they said there wasn't any life on Mars because it looked so desert-like. I said, well, that looks just like Tucson, Arizona. So it turned out I didn't really believe it. But we're now finding that Mars is a lot more interesting than we thought. These are recent pictures. The picture on the left is a crater near the poles of Mars, and you can actually see the white material. It snows on Mars. That's new discoveries that we had. And on the right, we had a probe that NASA landed on Mars a few years ago called Phoenix, and it dug into the soil, and these were at higher latitudes, and just beneath the surface, there's ice virtually every place on Mars. In fact, there's so much ice that if we melted all of it, it would form an ocean 200 meters thick on Mars. This is a fairly recent picture, but you see those dark fingers? That's actually water that is flowing. You see a mountainside that has glaciers on it. You see water flowing on the surface of Mars. Now, one thing to remember is that every place we find water on Earth, we find life. So this is one place that we may look for life. The Mars Science Laboratory Curiosity landed about a year and a half ago. It's been able to show that water flowed on Mars maybe as recently as 1 million years ago. So Mars is potentially a very, very good place for life. Now, there's other places in the solar system. This is Venus. Venus is where Mars is just a little bit out from the sun. For Earth, Venus is the next planet towards the sun. Its surface is very hot. It's something like 800 degrees centigrade. A little too warm. I just came here from Saudi Arabia. It's even warmer than Riyadh. So we wouldn't go there to look for life. But in the upper atmosphere of Venus, the temperature is very much like it is near the Earth's surface. So we're going to look in the upper atmosphere of Venus to see if we can find life. Now, throughout the solar system are a bunch of moons, like our moon. Most of the big planets have large moons. And we're beginning to think that some of those moons could have life. This is a moon of Saturn called Enceladus. It's right outside Saturn's rings. But a few years ago, we discovered with the Cassini mission, you see those little bright things? Those are water sprays that are actually going into space. And remember, again, any place we find water, we might find life. So we're going to go look around the moon of Saturn. Now, even more interesting, this is a big moon of Jupiter, Europa. It's about twice the size of our moon. But we've begun to study it, and we see that the surface is ice. It's frozen, it's maybe kilometers thick. But underneath it, we're pretty sure there's a big ocean, an ocean of water. At the bottom of that ocean, just like there is on Earth, there's volcanoes that are producing energy. And what we find on Earth, where we see these volcanoes underneath the ocean, we find life. Also, we just recently found that on Europa, there's also water spraying into space. So very, very interesting location to go look for life. Now, this is Saturn, the biggest moon, Titan, which is almost the size of Mars. It has a fairly thick atmosphere. It has lakes on it. You can see one of those lakes there. You can see the biggest lake in North America, Lake Superior by comparison. The lakes on Saturn's moon Titan are not water. They are ethane and methane, petroleum basically. So it's another place like Saudi Arabia that there's lots of oil. It's a long way to go to get it, however. But there could be really strange life that could live in this this hydrocarbon sort of chemistry. So that's a place we would also look. We are building CubeSats, these small things again that we think can actually fly out into the solar system. In the past, remember, it cost maybe billions of dollars to get there. We think with a few $1 million we can actually begin to do this. So this opens up the exploration of the solar system to a lot of different nations and groups. Now, let me talk about outside our solar system. There's maybe 10 billion stars in the galaxy. And there's probably 10 billion galaxies. So we had this mission a few years ago. This is a mission that Ames developed, and we built it jointly with one of the other NASA centers, the Jet Propulsion Laboratory. And we've looked at about 150,000 stars that are like the Sun, other stars in our galaxy. And we thought that if there are planets around them, some of those planets would be orbiting in an orbit around the star, this edge-ons, which are our line of sight. So as the planet goes in front of the star, you'll see a small decrease in the light. And so we've been watching these for about 5 years, and we found that we found thousands of planets. Indeed, we now think that just about every star in our galaxy has planets, and that probably a quarter of them have a planet about the size of the Earth in what's called the habitable zone, which is the region where liquid water can exist. So we found a lot of these planets in other solar systems that are about the size of the Earth and could have life, but we don't yet have the means to prove whether they do or not have life. We find really small planets that you can see our solar system there on the right, and you can see some of these other solar systems that we're studying that have planets that are not much bigger than the moon. Now, when I went to school a long time ago, I was told, that I was an astronomer, it was noted, I was told you couldn't have planets in star systems that have multiple stars, that they couldn't form. The scientists said, well, they couldn't possibly form, except that Kepler found that a lot of these, they're called binary stars, have planets. Indeed, the first one we found kind of reminded us of a movie. You might remember the Star Wars movie that Luke Skywalker was living on a planet that had 2 stars. The nice people at Lucasfilms allowed us to call this first planet we found Tatooine and changed it to look like, if you were on the surface of it, what the sun would look like, except there would be 2 of them. Now, I'm not going to get into a lot of detail here, but what would we look for on a planet around some other star to prove that it had life? Well, if you look in the solar system, if Mars and Venus have life, it's not very much. And their atmosphere consists mostly of carbon dioxide. However, if you look at the Earth's atmosphere, there's not much carbon dioxide, but there's a lot of oxygen. Now, oxygen is what's called a non-equilibrium gas, which means if I put it in a box with other things, it quickly combines to form other elements or compounds. And so it doesn't exist very long unless there's something to maintain it, like life. So in the case of the Earth, the life on the Earth maintains the atmosphere with a lot of oxygen. And we also see the other difference is we see water, a liquid. So the 2 things we're going to look for to find evidence of life is water and a non-equilibrium gas like oxygen. So we have 2 missions that all of NASA is working on. This particular one, Ames is working on with one of the other NASA centers called NASA Goddard, and with Harvard and MIT universities, that we're going to look for all the nearby stars to see which of them have planets that cross in front of the star. And then in about 4 years, we're launching this, which is the Hubble telescope replacement, called the James Webb Space Telescope. And we think that we might, just might, be able to find evidence of life by the end of this decade. But if we don't, we're going to have to go to a more complicated system. Now, if you want to find a planet around a nearby star and actually image it directly, take a picture of it, that's pretty hard because the planet is a billion times fainter than the star, so you have to have a special instrument called a coronagraph that blocks the light out of the star. And those are pretty expensive to do. So, but we're working on that. Now, let me talk about expanding into the solar system, about humans. Now, the first place that people have talked about, and this is mostly science fiction, but it could be real, is that we could build cities on Mars. But that raises a question, what if there's life on Mars? Now, about 20 years ago, some scientists discovered this rock on the left in Antarctica. Now, if you see rocks on the ice in Antarctica, it's kind of hard to get them there unless they fell from the sky. And so these are meteorites, pieces of space junk. This rock, we're pretty sure came from Mars, because if you looked inside, you found little trapped bubbles of gas that matched the Martian atmosphere. But some of the scientists found these little kind of structures inside the rock they thought might be fossilized bacteria. Now, we now don't believe this is evidence of life, but this was an interesting story because NASA went over and told the President of the United States right away. Unfortunately, one of his assistants told his girlfriend before the President could make an announcement, and the story got all garbled up, so in the future we might not tell the President, particularly if somebody talks to one of his friend's girlfriends. But the good question is, what if there's life on Mars? Now, this is a secret picture taken from one of our probes, but it does raise the question that is it an ethical issue? If there's life on Mars, can we go live there? And some people would say, well, we're worried about us killing that life. Others would say they're worried about that life killing us. Fortunately, there's other places in the solar system we can live. This is the moon. Now, we went to the moon almost 50 years ago, and it was pretty dry and barren again. But we had a mission that NASA Ames did, where we actually took and directed the upper stage of a rocket into a crater near the pole of the moon and we found lots of water frozen in the bottom of these craters. So we believe at some point we might be able to live there. Now, this is the mission we currently have in orbit around the moon that's studying the moon's atmosphere. Now, you're told in school the moon doesn't have an atmosphere. That's not quite correct. It has a very, very thin atmosphere. There might even be dust storms in it, so we're studying that. This was a low-cost mission that was launched in September. Now, I put this picture up. You notice the frog. When the rocket launched, it seems there was a frog sitting nearby. So it also launched the frog. Now, my wife saw this picture and she said, "Was the frog okay?" She didn't care whether my spacecraft worked. So I told her, yes, of course the frog was fine. I'm not so sure, but we never found the frog. But the other interesting thing about this rocket, this was a military rocket. It used to be an intercontinental ballistic missile that carried nuclear weapons, and we reworked it so that it could do peaceful stuff. And this was a picture of, this was taken over New York City, and you could actually see the rocket launch from New York City. And I found it quite exciting because I was a general in the Air Force, and I always thought if I saw a rocket like this launched over New York City, it would be a nuclear war, it wouldn't be very good. But in this case, it was very good because we went to the moon with it. Now, just to show the kind of things we can do in space, this other mission here on the left is the Lunar Reconnaissance Orbiter. It was launched at the same time as that mission I told you about that ran into the moon. It's still orbiting the moon, but the other picture on the right is one that it snapped of our mission landing. This is the first time around another world that we took one spacecraft to take a picture of another, and we were able to reconstruct this image of it by, because it was smeared. But very, very interesting ability to do far away. We're very proud of our capabilities. Now, from these studies, we found lunar ice, this stuff in the poles, moon, all of these materials in it. This is the stuff of life. So even the moon has the basic ingredients that enable us to live there. So if we can't go to Mars because the Martians are not very happy about it, we can potentially go to the moon because we're pretty sure the moon doesn't have any life. Now there's other places in the solar system that are pretty interesting. These are asteroids. Now asteroids are the leftover stuff of the formation of the solar system, a bunch of small rocks. Some of them have a lot of ice. This one, for example, is Vesta. It's a big one. It's just beyond the orbit of Mars, between Mars and Jupiter. And it's smaller than our moon, but it and some of these other asteroids have a lot of ice. Again, remember, water is the stuff of life we're looking for. A few years ago, we had an artist say, well, why should we need to go there? Why don't we drag one of those asteroids back into Earth orbit? So this was kind of an artist's conception. But it turns out now, as I'll show you later, that we're actually going to do this. NASA's next big mission is to grab an asteroid, bring it back near the moon, and go visit it. Now, the other question is, when we go and live on other worlds, what do we mean by us? And we think that we're going to have really capable computing, maybe even artificial intelligence. The next big step in computers is something called quantum computing. These are computers that can imitate human thought better. And the first one of these has been built here in the last year. There's 3 of them in the United States. This is one that we have. We teamed with, again, my rich neighbor who bought it for us. It's the first generation quantum computer. It's a very, very exciting effort. And again, we hope that some of you will come and work with us on this program. The other effort is, I mentioned synthetic biology, so that we can actually engineer biology. So you could live on another world by programming the biology to build pharmaceuticals, to extract the material from the rocks, and so forth. So this is a very, very exciting effort. Now, to show how this would work, this is cyanobacteria, which is maybe the oldest living stuff on Earth. Indeed, cyanobacteria, we believe, is what turned the Earth's atmosphere from that primitive carbon dioxide into the oxygen that we can breathe. It's photosynthetic bacteria, so what that means is it takes sunlight and minerals and other elements that we see on the moon or other places and convert it to useful stuff like sugar and other kinds of food or oxygen so you can breathe. So the idea in the future is that if we live on another world, we wouldn't need to transmit stuff there. We just transmit genetic code, and then you can print out the genetic code, and so you transmit stuff via radio. Now, this is called bioteleportation, and the idea is maybe we can even transmit ourselves over these very great distances. And you might say, well, that's pretty science fiction, although it's being done today. I remember I mentioned Dr. Venter. He wrote this book recently that talked about this, and I saw the book and I said, well, this is pretty, wonderful stuff. When do you think we could do that? 50 years? He said, no, we can do it right now. So this is Dr. Venter out in the desert. There's a desert in Southern California that's the closest we can get to Mars. He's also a motorcycle nut. So we went out and did this test. We had this laboratory that was in a van. Eventually, we think we could make this smaller and send it to Mars. And this is a rock you find in the desert. And you see that kind of green stuff on it? I'm not a biologist, so I just call it stuff. That's cyanobacteria that's growing on the bottom of a crystalline rock. This is the kind of life we might find on Mars. So we got some of this rock, and we then took it to this laboratory. Now, we did it on Mars. We have robots other than these scientists. But we were then able to sequence it in this machine, just put some of it in there, and send it back to his lab, and we're going to try to reassemble the genome. So really neat things going on. Well, I'll stop there, and I want to show you a quick movie, and then I'll be happy to take some questions here.
2013 was a big year for Ames Research Center's space exploration programs, including several new launches and continuing a long history of cutting-edge innovations. Designed and built at Ames, the Lunar Atmosphere and Dust Environment Explorer, or LADEE mission, was successfully launched and sent to orbit the Moon to conduct science operations. The spacecraft is studying the extremely thin atmosphere or exosphere of the Moon and measuring the amount of dust found in this region of space. Ames is managing the science operations for the LADEE mission, as well as commanding and controlling the spacecraft using the Multi-Mission Operations Center. This facility is also being used by controllers for the Interface Region Imaging Spectrograph, or IRIS mission. The IRIS spacecraft successfully launched this year on its mission to study the region of space around the surface of the Sun. Using state-of-the-art imaging technologies, IRIS is gathering extremely high-resolution data about the energy released from the Sun that creates what is commonly referred to as space weather. The Kepler mission continues to make groundbreaking discoveries and redefine our understanding of planetary systems and stars in the galaxy. The team has found hundreds of new planet candidates this year and continues to discover smaller, Earth-sized planets orbiting in the habitable zone of their sun-like stars. For Ames researchers, 2013 could be called the year of the nanosatellite. Several of these tiny satellites were built and sent into space, including the innovative PhoneSat CubeSat.
I want to mention either of those
PhoneSat
guys
was created as a
US
technology demonstration
doing a lot of work
to prove that a
with
satellite based on a smartphone could function in space. This year, the team successfully flew 4 of the tiny satellites in space, and future versions are already in development. The TechEdSat CubeSat was also built at Ames as a technology demonstration. It tested a new exo-braking parachute system that could allow satellite payloads to safely re-enter the Earth's atmosphere.
This shows satellites being
In collaboration with the Air Force, a team at Ames built the first nanosatellite launch adapter system. NLAS is designed to launch multiple CubeSats from rockets that could previously only carry 2 or 3 at a time. The Intelligent Robotics Group at NASA Ames is working to improve the capability, functionality, and reliability of robotic systems that are key to the future of space exploration. On 3 different occasions this year, astronauts on the International Space Station remotely operated the Ames-developed K-10 planetary rover located at the center's Marsscape. These tests were the first time an astronaut in space controlled a rover on a planetary surface. 2013 was also a year that Ames researchers conducted experiments on the International Space Station to better understand the effects of microgravity. Seedling Growth 1 was designed to study how plants respond and adapt to a range of low-gravity environments. The results of these studies could be key to supporting astronauts for long-duration space missions. Ames also developed the cell biology technology demonstration. The system is a simple yet highly effective method for conducting cell biology tests while in space. A team at Ames tested an innovative and compact heat shield that could expand like an umbrella to enable much larger payloads for planetary entry than are currently possible. Wind tunnel tests on models of the NASA Space Launch System were conducted at Ames to help improve the design and stability of NASA's next heavy launch vehicle. This summer, NASA launched Spaceloft 7 and Spaceloft 8, 2 suborbital rockets from Spaceport America near Las Cruces, New Mexico. They achieved a record altitude of 73.9 miles while carrying a variety of experiments in microgravity. Ames manages the selection and development of payloads for the suborbital flights program. The Curiosity rover continues to explore the surface of Mars, and a team from Ames is using their X-ray diffraction instrument called CHEMIN to analyze the soil and find out exactly what minerals it contains. Ames researcher David Blake developed the CHEMIN instrument that is one of the key tools being used to identify whether the conditions for life could have existed at one time on the surface of Mars. Using instruments on the Mars Reconnaissance Orbiter, researchers from Ames and JPL are working to see if a form of salty water is responsible for the seasonal slopes that appear on the sides of Martian hills and mountains, an area where scientists generally believe conditions to be dry. Researchers in Ames worked in partnership with the Russian Space Agency on a life science experiment called Bion-1. The mission was to study how life adapts to microgravity in space and then readapts to gravity on Earth. The Ames-developed Pioneer 11 spacecraft reached its 40th anniversary in space. Launched in April of 1973, Pioneer 11 flew past Jupiter and Saturn and collected tremendous amounts of data about both before communication with the spacecraft ended in 1995. As they did in 2013, scientists, researchers, and staff are hard at work to continue their mission to make new discoveries in 2014 and beyond.
Well, thank you, and we look forward to working with you.
Thank you very much. Let me just show again a
Very good question. You know, to get around in the solar system, like you said, all we need is, physics we do for hundreds of years, Newton's laws of motion. But one of the other things NASA does, in addition to studying the origin of life, is what's the origin and structure of the universe, particularly are Einstein's theories correct? And we're beginning to do some studies on that. In fact, one reason I'm in this region of the world is we have a joint project with the Saudis to study, to see if we can see gravity waves. Gravity waves are, nobody's ever seen them. They're theoretically predicted by Einstein's theories. And you probably could see them if black holes are emerging in the center of our galaxy, for example. So we think by the end of this decade we might be able to see that, again, using fairly small satellites. So we're very excited about, is Einstein correct? Nobody knows. And so that's one of the very exciting things we can do from space. Those are called gravity physics experiments. So a good question, and we hope some of you will come and work with us.
questions.
Hi. How far has NASA gone with research in other galaxies? And have you found anything out about those galaxies?
Well, we do a lot of work on in astronomy. Some of it's on nearby stars and our own galaxy, but there's a whole field of extragalactic astronomy and cosmology. Indeed, most of what the Hubble Space Telescope does in its follow-on, the James Webb Space Telescope, is to study the distant parts of the universe. So we do a lot of research on it. In fact, the primary instruments are these space telescopes. We also study the distant parts of the universe in other wavelength regions, X-ray radiation and radio radiation. So it's a very exciting effort, and these new instruments are going to be very, very useful in doing that. Indeed, at Ames, we planned a mission called the Dark Ages Explorer. The first few 100 million years of the universe, you couldn't see anything. There wasn't any radiation. It turns out there is a little bit, but if we could, the only way to see it is to block out the interference from the Earth, so we're planning to go on the other side of the moon and observe the early part of the universe, and that's really looking at these distant galaxies and regions that we don't study. So we do all kinds of astrophysics. Very exciting area.
I've heard recently about the M theory, so can you please tell us what is it and how does it impact our galaxy?
What was that again?
The M theory.
The
M theory.
M theory?
Yes.
I'm not familiar with that.
The reincarnation.
Reincarnation theory. Again, that's an area that is pretty speculative, and I don't think NASA's doing anything to study it, but the more we find out about the universe, the more you can find out about some of these more exotic theories of how life began and how it works, and even the spiritual dimensions of it.
Guys, this one down here.
Hi, my name is Mariam. Is our Earth going to destroy or something? Because you're talking about going to other planes, what's happening to our Earth? I know about the global warming, sorry.
Well, that's a very good question. I mean, a lot of what NASA does is study other planets, and we think about traveling to them. But one of the most important things we do is study our Earth. Most of the data that we've got enables us to understand climate change and global warming comes from NASA sensors. So one of our primary things that people don't talk about enough is how we can help fix this planet. Maybe a few people could go live on Mars, but most of us prefer to live here. So one of the important things to do is to develop technologies to study the Earth and to actually fix things. So that's a very important part of what we do is to figure out how to do things with less energy, how to understand what's going on to our climate, and things that we as humans can do to fix it. So it's important that people don't understand we're just doing things on other worlds. I don't intend to go in another world. I want to live here.
Hello.
Hey.
Yes. You've mentioned NASA being in the 12th spot in terms of advanced computing. So what is NASA doing to tackle that ranking?
Well, again, these rankings, there's a speed program that you measure your performance. Every year they do a new test. A variety of groups around the world have tried to just win that test. To us, there are other things that are important. One of those is how cheap is it to run the programs and how general purpose it is. We're happy if we're in the top 10 or 20. But the other thing we're doing is trying to develop this new computing I mentioned, quantum computing. In principle, quantum computing can solve some problems that could never be solved on a conventional computer. So we think that although the speed test is important, that the other thing is the new technologies that will enable us to do much more complicated problems. So that's why we're working with Google and others to develop new computing approaches.
Over here.
Hi. Did your NASA find any bulkheads at space when you go to out to Earth?
We find any, what?
Did you found any bulkheads at space when you go to out to Earth?
I didn't quite understand the question. Do we find other life?
Did you found any bulkheads at space?
I can't catch that word. Particulates?
Did you found any pictures at space?
Pictures?
Yes.
Oh, Earth space. Well, you know, of course, a lot of the missions we have, their purpose is to take pictures of the Earth. And you use those pictures in order to understand what's going on the Earth. That's one of our primary purposes. So some of our spacecraft, even far out in the solar system, have turned the cameras around to take a picture of the Earth. What does it look like from way far away? It's a very interesting set of pictures. You can find them on the internet.
Over here.
I just want
Two more then, two.
Yeah, so go
Two more
ahead.
questions,
Yeah.
one and then two.
The previous Prime Minister of Canada once mentioned on stage that the US has aliens and they're dealing with them secretly. What's your take on that?
Well, I wish we had them because we'd get more money from our Congress if we could show the scary aliens. You know, I don't know of any evidence of aliens, and I said if I did, I would certainly tell everybody. I wouldn't keep it secret. But it's an interesting question. You know, there's an organization that was founded at Ames about 30 years ago called the SETI Institute, Search for Extraterrestrial Intelligence, and they've been looking to see if they can see signals from aliens. So far they haven't found anything, but it's a very important search that, you know, the first thing that we're trying to do at NASA is at least see if there's life, you know, probably microbial life. But if we find life on other planets in our solar system or beyond, it's almost inevitable that there would be intelligent life someplace else. We certainly don't yet know how to look for it other than to start with each one of these points.
Okay, I have another question.
Go ahead.
Okay, a long time ago, a while ago, the Russians had a problem with the USA concerning NASA and, you know, space stuff. Can you mention that? Because I don't really get it.
Well, you know, there's always political arguments back and forth between various countries. In the 1980s and 70s, we had a space race in the 60s that we were both trying to go to the moon, but we also were doing a lot of military space activities. I was personally involved in something called Star Wars, the SDI program, which was building space weapons. The Russians didn't like that because we were doing it better than they were. And it turned out that the Cold War ended, and one of the reasons it ended was that we came to an agreement. So today the U.S. is not building space weapons, but that was an old argument. We still use space for national security purposes. We use it to verify treaties. We use it to help the military, and the Russians do as well. Today we're doing most of our space work in cooperation with the Russians. You saw on my movie that we did this experiment last year where the Russians launched a biological experiment that we worked closely with them. So we're sort of moving from, in the past, competition to now cooperation. So it's been a big change. Right. Well, thank you again.
I realize the questions could probably go on and on because it's a topic that we could just talk on for a long time. So thank you for your questions, but we have to call it a day there. Can I ask you to remain seated while our guests leave, please?